All right, so there we go. Oh, come on. Oh, because it's frozen. There we go. Okay, so where d of x, which is our denominator, it cannot be 0. Okay? All right, so a rational function is the quotient of a polynomial. And d of x cannot be 0. So, if you can remember back a little bit in Algebra 2, this is where all those random dotted lines that you cannot cross appear. Do you remember what those random dotted lines were called? It was a weird word.
How does it start with?
A.
It's like
Asymptotes. Yeah.
There,
Real
I
weird
have
word. Asymptotes. So we're going to look at vertical asymptotes, horizontal asymptotes, and oblique asymptotes. All the above. Okay? So first, this is a review from chapter 1, I think. Go ahead and tell me my domain in interval notation. Domain and interval notation.
all of them or just number 1?
All of them.
I like these problems, like number 1 and algebra 2, where you would like cancel out x minus 3. I don't know what those are called. Like,
We will be crossing things out.
yay.
He's done wrong with the answer.
Right now, we're just worried about the domain, but yes, we are going to be crossing things out. Right, so for the first one, we know that x minus 3 can't be 0, so x can't be 3. So if we set up a number line, it can be anywhere before 3 and anywhere after 3. And we can denote that with just using parentheses. So negative infinity to 3, parentheses, 3 to infinity. Okay. What can x not be on number 2?
3 and negative 3.
3 and negative 3. So I can be anywhere before -3, between -3 and 3, and after 3. And the last one, what can X not be? It could be what?
That's 2. Oh, yeah, you're right. 2 and -2.
Okay. If you wanted to, you can set 4 minus x squared not equal to 0, and we subtract our 4 and divide by a negative, and then take the square root. Then we get our plus or minus 2. So same thing as the number 2, it'd be from -infinity to -2, -2 to 2, and then 2 to infinity. Okay? So that is just our domain. That has no meaning of this is a vertical asymptote, this is a hole in the graph, this is this is that. This is just everything. This is everywhere I have to take my pencil, pick it up, and start drawing again. Okay, so this includes all of the restrictions on the domain. Now we're going to get a little bit more specific and figure out what is causing what. Okay, so we're going to check our asymptotes. This is all on, I usually write it over there on the board, but I want to be able to go through each one individually. Okay, so vertical asymptotes. This is whatever makes the denominator equal to 0. Okay? Vertical asymptote.
Can you scroll back up so I can see what it's called? Okay, thanks.
And it also says, here, let me scroll this down too. There we go. Asymptotes are invisible lines that the graph never touches. So this is whatever makes the denominator 0. And we'll talk about something else that is also going to be located there as well.
I don't like graphing.
You don't, or you do? You talked.
Okay.
Should we announce our name before we say it?
No, I just be patient. And
Well, I
understand.
know, but it's probably frustrating, and so I feel like it'd just be easier on you.
Yeah, no, that would be so silly if you did that. Don't do that.
But sometimes silly is what works.
I think it's because, I don't know. You would think I would always think it was you, but
Is it because you're becoming an older woman? I just wanted to see what you'd say. I just wanted to see what you'd say. What is your response?
Dang.
What?
Why would you say that?
Because I wanted to see what you would say.
She didn't say anything. She just
I know, and that's the best response. That means that I struck a nerve.
You're gonna go see David.
Do you like my UTK hoodie?
I've already here.
are y'all just wanting to hate on me today? Like literally of all days?
There's nothing wrong with being old.
Dang!
God,
I didn't say you were old
yet.
But hopefully you will be. I want you to have a long life. What? It's a good thing if you're old, because then that means that you've had experience. And you might have grandchildren.
Yeah, I want you to be at my funeral.
Moving on.
You don't want your son to grow up without a mother. So you want to be old.
Stop talking, man.
I'm just saying. It makes sense.
This was not in the faculty meeting yesterday. This was not what. This is the thing I probably should have been prepared for.
What if the faculty meeting was just...
Okay, so must be in lowest terms. In other words, okay, this is what we were talking about earlier. If something crosses out, that is a hole in the graph. Okay, If you have a common factor that crosses out, you have a hole in the graph. All right, and there's a difference between having a vertical asymptote and a hole in the graph. See here how x minus 3 and x minus 3, there's one in the numerator and one in the denominator. So technically I would cross those out, and since I crossed them out, I would set it equal to 0, and that's where the hole in the graph would be. Okay? And then notice how since I crossed it out and there is a hole there, there is no longer a vertical asymptote there. Okay? So the only vertical asymptote that you'll find is at x equals -4. Okay? And that's because x plus 4 is the only thing that's left.
Are we gonna do this stuff where you have to like factor out like the trinomials or whatever?
You'll have to factor.
Yes.
Yep.
Bro.
Yep, you have to factor here. So if you cross out common factors, that is where the hole in the graph is going to be. But whatever's left in the denominator is where the vertical asymptotes are going to be. And not every time you're going to have a hole in the graph, okay? So don't say, oh, I didn't cross anything out. A hole is not something that's going to be in every single graph. Notice how they are still domain restrictions. The problems that we just did, I didn't have y'all factor and cross anything out. Y'all went straight to the denominator. So the domain, again, includes all the things. All right? So that's your vertical. All right? Then we have horizontal asymptotes. I have weird little sayings for all of them. You can make fun of me for them if you want, but they will help you remember them. Vertical asymptotes are literally a restriction on the domain. Horizontal asymptotes are more of a guideline, okay? You can cross a horizontal asymptote. And usually it's only because it's on the actual x-axis, okay? So you can cross a horizontal asymptote. So you're going to compare your degrees, all right? And that's why I had these little sayings. So if the numerator has the highest degree, I say, no way, top can't win. So there's no horizontal asymptote. All right. If the denominator has the highest degree, I say yo at the bottom. It's y equals 0. That's why it's yo. And then if it's a tie, meaning they have the same highest degree together, you're going to put the leading coefficient over the leading coefficient, and then that's going to be your horizontal asymptote. They're weird to see in all of this right now, but then when we start doing examples, hopefully it'll click and make a little bit more sense. But you're comparing the degrees, which is the highest exponent, and you're determining from there.
That's where the one. So like if the highest one's 3 on the bottom, that's like where it would be.
So if the bottom has the highest degree, it's y equals 0. So that's what's in teal here.
So it's just,
Mm-hmm.
gotcha.
This would be no horizontal asymptote. And then let's say you had 2x squared over x squared. Then your horizontal asymptote would be y equals 2 over 1, which would just be 2.
Did you just call that gray teal?
It's teal here.
There it is. Oh, it is. Oh, it is.
All right, guys.
It's
Did y'all just, get a group chat going today?
No, we had a faculty.
not that
member.
we have fun.
And they said, give your teachers as much difficulty as possible.
Perfect.
It was a speed-led thing, so bringing them.
Yeah. I mean, he doesn't have to deal with it anyway, so.
Yeah,
And even if he did, he'd just give it to the council.
Oh, me.
What if he's on the faculty meeting and it was just him like
I'm the
making
best
fun of each
principal you've
teacher
ever
individually.
had.
And like he'll just go down the line and just say something that we mean, and he'd get done to you and he'd just say old and then move on to the next person.
Yo, I'm 34.
I'm not saying you're old. I didn't say that.
You did.
Just did.
No, I said, is it because you were becoming
Twice.
an older woman?
Twice.
Older than where you were a few seconds ago. You are aging technically, as everyone does.
You
There's
are
nothing
aging
wrong with
technically. Perfect.
it. There's nothing wrong with it.
Okay, so the first example, notice how the numerator, hey y'all, the numerator has the highest degree, 2 versus 1. Okay? So I said, no way, top can't win. So that would be a no horizontal asymptote. That would be your answer is no horizontal asymptote. Okay? Over here, since it's 1 versus 2, 2 is in the denominator has the highest degree. So I say yo at the bottom, so it's just y equals 0. So you would have a dotted line at y equals 0. And then here we have x squared and x squared, so we would take our leading coefficients, which would be 2 over 4, which if I scrolled this over just a little bit, you would see the 1/2. Okay? So then I would draw a dotted line at y equals 1/2. Okay? So those are 3 different examples of how that will look. So again, we're comparing the exponents. Oh, come on, let me write. It's not letting me. It doesn't want to let me write. All right, so now there is a special asymptote that stems from this example right here. If you have no horizontal asymptote, there is a possibility to have an oblique asymptote. Okay? An oblique asymptote is also called a slant asymptote because it's literally a slanted line. Okay? You check only if you have no horizontal asymptote. How do we find that? We do long division. But the big deal here is it must be 1 degree apart. Why does it have to be 1 degree apart?
Oh, so it's linear.
Yeah, so when you divide, you end up with a line, okay? So if you have x cubed divided by x squared, you're left with x. If you do x to the 4th divided by x cubed, you're left with an x. We want an equation of a line, so that's why it has to be 1 degree apart.
Maybe an asymptote that's like a quadratic.
David's not
All right, so for example, x squared plus 3n over x plus 2. Notice how that's the exact same example we had where it said no horizontal asymptote. So then we would use long division, but do not use the remainder. That's huge right there. Make sure you don't use the remainder. So if I did long division, just to show you quickly off to the side. I would end up with a remainder of 7, but I'm not interested in that. I'm only interested in this part right here. Okay. So that's how we would get our slant asymptote. And you would graph it like you would graph any average line. Okay. -2 is your y-intercept, your slope is 1, then you would just make sure it was dashed. Okay? Questions so far? Like I said, it's a lot all at once, but these problems are going to be all at once. So I want to make sure that you are able to get all this information together. So then that way, when you actually do a problem, it's not, oh, I'm so used to just doing things separately, which we are going to practice them separately first before we graph them. Okay? So only find my vertical asymptotes and holes here. Okay? Vertical asymptotes and holes. Trying to get it so where y'all can still see it. No. That's not going to work. Okay, vertical asymptotes and holes.
All of them.
How do you notate it?
Do what?
You just how do you notate it? Do you just put x equals?
X equals their equations of a line.
Okay.
And then the holes, I usually just put hole at x equals whatever. So step 1 should be always put it in simplest form, aka factor it.
Should you find the asymptote before or after you factor everything?
I'm sorry?
Were you trying to asymptote before or after you factor everything?
After you find the, well, technically in all these problems, no matter what, you're always going to factor.
Yeah, but like for number 5, you find the asymptote, like.
You still need to factor first because then it'll determine if it's a hole or an asymptote. All right, so for the first one, we can factor x plus 1, x minus 1. Can I cross anything out? No. So my vertical asymptote would be x equals -1 and x equals +1. So I would just draw dashed lines at -1 and +1. Okay? Same factoring over here. However, these can cancel. So we have a whole at x equals what? 1. And then we have a vertical asymptote at x equals -1. Okay? Still 2 restrictions on our domain. Still going to be an issue there. One's just going to look different than the other. Questions so far on those two? Number 6 is the same, but switched. So I get that there is a whole at x equals -1 and a vertical asymptote at x equals 1. Okay, on number 7, you have to do factoring the long way, which is fine. I'm going to start up here to give myself some space. What are factors of -12 that get me -1? -4 and 3. So 3x squared plus 3x minus 4x minus 4. I can take out an 3x here. I'm left with x plus 1. I can take out a -4 and I'm left with an x plus 1. I said x plus 1 twice and a 3x minus 4. So that's our denominator. Nothing can cancel out with our numerator, so we have 2 vertical asymptotes. And they're going to be at x equals -1 and x equals 4/3. Do it. If you still need help on that factoring, come see me during study hall. Make sure we know how to do that way. A lot of times I try to help you out as much as I can with problems that can do the shortcut because, again, technically you've already learned all the factoring. It's more so I want you to know this stuff, so it should move pretty quickly. But okay, so number 8. I could make this into one fraction, but if I have to have a common denominator, it's just going to be the same. Okay, so I'm just going to go ahead and say that my vertical asymptote is x equals -3. Now, when you get to a problem where you have to find all the asymptotes, then yes, you're going to need to make that into one fraction. Okay. And over here, if we have x plus 1, x minus 1, all over x minus 1, if those cancel, we only have a whole at x equals 1. Notice how nothing is left in our denominator, so we don't have any vertical asymptotes. These are the ones that look really weird because they would end up just being a straight line. And then whenever you got to, I don't think it's going to let me change it. But whenever you got to 1, wherever 1 might be, oh, let me do like a little dot. Okay, it's not letting me do it. But it's gonna make a big old dot here. Oh no, it didn't. Yay. Okay. So whenever you get to 1, you would just have a hole in your graph. There. Okay. That's how it ended up looking. And you're gonna make an obnoxious hole in the graph. Like you're just gonna be like, there it is. Now, if you look on your calculator, you won't see it at all. All right, but that's how it looks. Questions on holes or vertical asymptotes? All right. Let's look at some horizontal asymptotes. Go ahead and tell me my horizontal asymptotes for those 3. Right. Who has the highest degree on number 10? Denominator. So as bad math language as it is, the bottom does. So the bottom wins. So yo at the bottom. So literally, it's just y equals 0. Yo at the bottom. Who has the highest degree on number 11? It's a tie. They're the same. Squared and squared. So we would say y equals 4 over 2, which is y equals 2. And lastly, who has the highest degree on number 12? No way, top can't win. So no horizontal asymptote. Is there a possibility of an oblique asymptote here? Yes, they are 1 degree apart. Okay, so let's say I also made you find the oblique asymptote. So go ahead and do long division to find our oblique asymptote. You can only have an oblique asymptote if you have no horizontal asymptote.
Would we ever be able to do synthetic divisions?
No, well, I won't say never. If it was x squared and x, you could. through your first step, is there anything I can multiply 2x squared by to get negative 2x? No. So my oblique asymptote would just be y equals 2x. Okay, I don't care about the remainder, I don't care about whatever's left over, it's just the equation that's left at the top. It's gonna be linear, a linear binomial at the most. It could be a linear monomial. Okay? So vertical asymptotes, poles, horizontal asymptotes, and oblique asymptotes. So far, any questions? Besides, it's just another thing to remember for this test. Okay. Find all of the asymptotes. Put it all together. Find all of them. If they are asking for all of them and there are actual lines that say vertical asymptote, put your answer here, poles, put your answer here, horizontal asymptote, put your answer here, write none as opposed to 0. If you write 0, 0 is an answer, okay? So if nothing is there, you're going to write none. Don't just leave it blank. Don't put 0 because, again, blank means you don't know what you're doing, and 0 is an actual answer. So actually put none.
sure it's locked.
It definitely was.
I don't even gotta check the Google.
One more. Oh, man.
I think we should go check.
She's on the website, check.
So we're not quite there yet on looking at the zeros and stuff like that. We're gonna do that when we start graphing. But you can factor the numerator if we wanted to start getting in the habit of it. If I take out a -1, that's the same thing as x squared minus 1, which would be x plus 1, x minus 1. Like I said, right now it doesn't mean anything to us because it didn't end up canceling anything out and it didn't really provide too much information for us. But when we start graphing, today's Tuesday, come Thursday, then you will need that because that tells you the zeros of your function, okay? So we start off with vertical asymptotes. We look at our denominators, so x equals -5. What about holes? Do we have any? Okay, horizontal asymptote. Looking at the original equation, who wins? Top. No way, top can't win. Okay, you can put no horizontal asymptote for the no ha that I had on there too, or none. It doesn't matter. But can we have an oblique asymptote here?
Yes.
Yes, we're 1 degree apart. So, running out of room here. X plus 5 goes into -x squared plus 1. So we have -x. So we get 5x plus 1. So -x plus 5 should be our equation. Okay. So that's all of our information there. All right, 15. Cannot factor it, so we jump right in. What's our vertical asymptote? X equals 1. Good. Do we have any holes? Nope. Horizontal asymptote. Who wins? It's a tie. So y equals 2 over 1, so just 2. And because we have a horizontal asymptote, automatically we do not have an oblique asymptote. Okay. And lastly, for 16, get this out of the way. I'll scroll back up in a second. I can factor the denominator to x times x squared plus 3. So if I set x squared plus 3 equal to 0, what happens? What do we end up with? Square root of a negative number, which is imaginary. Okay. Even though they are imaginary dotted lines that we are drawing, this is not a vertical asymptote. We do have a vertical asymptote with just that x. So x equals 0. We didn't cross anything out, so the holes, we have none. Who has the highest degree? Top. No way, top can't win. And they are 1 degree apart, so we have to check for an oblique asymptote. So we have 3x, gets us 3x to the 4th, and 9x squared Draw our line, change our signs. We get negative 9x squared. Is there anything we can multiply x cubed by to get negative 9x squared? So y equals 3x. Okay. Any questions on those three? Okay, so today was focusing more on all the pieces, and then Thursday is going to be putting them on a graph. Okay. The only other thing we have to look for is our x-intercepts, our y-intercepts, and then additional points from there. Okay. Your homework should be in 2-6.